Hello everyone, today I will present a study that examines how the development of the digital economy affects particular matter 2.5. As the digital economy flourishes, its impact on the environment has become increasingly complex. This report will be based on our latest research to divide into the spatio-temporal economies patterns and nonlinearity characteristic between the digital economy and particular matter 2.5 concentrations, hoping to bring some new insights to you. This presentation will be divided into 4 parts. Firstly, I will introduce the background and significance of the research, explaining why we focused on this issue. Second, I will report the core research methods and models we adopt. Next, the most importantly, I will present our main research results and findings. Finally, in the fourth part, I will summarize the research and put forward corresponding policy and implications. First, particular matter 2.5 population is the global challenge, especially in China, where it seriously affects recent health and substantial developments of the economy. His results are complex, involving both nature and economic factors. Understanding how these factors influence particular matter 2.5 concentrates is the starting point of our research. Against this backdrop, our research focused on the digital economy. The digital economy is developing at an unprecedented pace, but its impact on the environment is complex and not a simple linear relationship. Existing studies have insufficiently explored this. Therefore, our research aims to fill these gaps and provide scientific support for green development from both a serious and a practical perspective. Next, I will introduce the core research methods and models we have adopted. A good research starts with a method, and the models we have chosen aim to address the challenges that traditional methods can't handle. Why do we need complex models? Because traditional linear models can address two core challenges. Firstly, the spatial correlations of particular matter 2.5 pollution. For example, pollution from neighbors dry over. Second, the nonlinear characteristic of the impacts of factors like the digital economy. To this end, we propose a flex effects partially linear adaptive spatial autoregressive model, which can handle both linear and non-linear relationships and account for spatial effects. Our research dates cover panel data from 34 provinces in China from 2011 to 2023. The dependent variable is particular matter 2.5 concentration, and the core independent variable is the level of digital economy development. Meanwhile, we also controlled for a series of important social economic factors such as population, energy, industrialization, and urbanization to ensure the research result. Now we move to the core part of the report, the main research results and findings. Our model has received some interesting and important results. The first important finding is the spatio-temporal evolution characteristic of particulate matter 2.5 pollution. As can be clearly seen from the figures, the gravity center of particulate matter 2.5 pollution in China has shifted from the eastern regions to the western regions over the past decades or so. This reflects the combined effects of multiple factors such as industrial transfer, difference in environmental policies, and geographic climate. The second finding is that particulate matter 2.5 pollution has a significant spatial spillover effect. Our model shows that the spatial autoregressive coefficient is as high as 0.4578, which means that the pollution level of one region is closely related to that of surrounding regions. Simply put, pollution from neighboring areas will drive to our home. These findings shows that the importance of the region's joint prevention and controls in air pollution governance. The third and the most core finding is complex nonlinear relationships among the influence factors. Firstly, regarding the digital economy, has impacts on particulate matter 2.5 presents a U-shaped relationship in the early days of the development. The digital economy curbs pollution by empowering the green transformations of traditional industry. However, after research at a certain stage, due to the huge economic subsections of infrastructure such as data centers and 5G base stations, as well as the increase in logistical emissions stimulated by online consumption. His presence on the environment space to emerge and pollution's main rebound. Let's look at the pollution's population size and energy intensity again. Their impacts on the particulate matter 2.5 shows a classic inverted U-shaped relationships. In early development, population growth and industrialization cause serious pollution, but as the economy and technologies advance, population shifts and then fast, showing socially abilities and willingness to govern the environment at a central stage. Energy strategies and civil hybrids also expect a U-shaped relationship. In the urgent stage, energy structures optimization such as coal-to-gas and the slow growth of ocean ships can indeed effectively reduce pollution. However, when energy structures optimization hits a burden, while heavy ocean continue to grow rapidly, the environmental pressures from exhaust emissions will exhaust the emission reduce affect the energy structure of chain migration, causing pollution to rise again. Finally, regarding industrializations and urbanizations, we found that their impacts on particulate matter 2.5 also show a U-shaped spectrum in the early stage has been stable in central years. This is a positive signal, indicating that in the stage of high-quality development, also effective policy guides and technologies progress, we can control the environmental pollutions and achieve coordinated developments while promoting industrialization and urbanization. Based on the above findings, we draw some conclusions and put forward policy implications. In summary, our research shows that the patterns of the particulate matter 2.5 pollution in China is undergoing dynamic change and significant spatial correlation. More importantly, we receive the complex nonlinear impacts of social-economic factors, including the digital economy on pollution. Based on this, we propose the following recommendations. Firstly, a region collaborative governments must be established. Secondly, a synergy imaging between the digital economy and green development should be built. Third, we should actively promote the green transformations of digital economy itself to avoid potential environmental rebounds. My presentation ends here. Thank you all for listening.